Hello everyone, I'm Frank and welcome to Frank Puzzles. And this is today's challenging level puzzle. And it's called Coordinated Chaos by Mello Robinson. And here are the rules. We have fill the grid with the digits 1 through 9 so that there are no repeats in any row, column, or region. And I think this is chaos construction. So that's why it's chaos. And yeah. Yeah, he has something for region building. So this is chaos instruction. So the regions are basically going to be orthogonally connected regions of 9 cells. So this could be potentially a potential region. Let's just get to the order of the rules that they have. We have coordinate arrows, where the digits on a green arrow give the coordinates of a cell in the grid. The digit at the base of the arrow indicates the row number, and the digit at the tip of the arrow indicates the column number. The reference cell is one cell of a domino, that is two cells that share an edge, that has the same sum as the digits on the arrow. Some of the arrows have no given arrow tip and must be deduced. So, for example, if this were, say, 6... Ooh, that's a color right now. 6 and 5. That would mean row 6, column 5, is a part of a domino. So it could be either these two, or these two, or these two, or these two, which has the same sum as the digits on the arrow. So it would have to add up to 11. So that's an example of what the coordinate cells, how they work, right? So again, the base of the arrow is the row number, so that would be 6. The tip of the arrow is the column number, and that would be 5. And that cell shares an edge with another digit which adds up to the same sum as the arrow. And some of the arrows have no given arrow tip and must be deduced. So these you have to have the arrow tip be deduced from these cells, these arrows. For region building, we need to locate 9 cell orthogonally connected regions in the grid. Both cells of a coordinate arrow are in the same region. The cell it references and the other cell of its domino are also in the same region as the arrow. Interesting. Okay, so that would be, if we had something like this, I think that would be problematic because these would have to be the same region. And this cell and the domino would be in would have to also be in the same region as the arrow. But obviously it can't reach there, right? If we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's 10 already. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 again. So that would not work because the cell that's pointed to by the coordinate arrow and its domino that adds up to the same sum as the coordinate arrow must all be in the same region. The digit in the cell with the small blue arrow counts the total of number of cells seen in the indicated direction, which are in the same region as that cell, including itself. So it includes itself. So for example, if this region borders block vision, and a cell with 2 blue arrows counts each direction separately. So, for example, if this were, say, a 2, it would say, in this direction, including the cell itself, how many cells are in that region. And it would say there are only 2 in this direction, and there are 2 in this direction. So it would have to be like, obviously this is its own region, but say this was 2. If this was 2, it could be something like this, and then that's done. And that would be valid as a for the arrows, for the small blue arrows to work. So again, for arrows that are pointing in 2 directions, you count each direction separately. So for example, this would be 1, 2 going that way. This would be 1, 2 going that way. And those are all the rules. If you like to play along, there's going to be a link in the description. And now I'm going to get started. Let's go. Okay, so let's start with the blue arrows because that's more limiting. This could be either 1 or 2. This is 1, 2, or 3. This is 1, 2, or 3. This has to be 1 or 2, and it cannot be 2. So this is 1, which means going this direction, it can only have itself, right? Because it must include itself in the number of cells seen in that direction. And region borders block vision, so it only sees 1 this way. This has to be 1, 2, or 3, and this is 1, 2, or 3. Because again, it's 1, 2, 3 that way, and this is 1, 2, 3 that way, 1, 2, 3 that way. This is 1, 2, 3 at most. This is 1, it can't be 1 or 2, so it's at least 3. It could be up to 7. 3, 4, 5, 6, 7. This sees 1 through 5. This is 1 through 9. This is 1 through 7, but 7 can't be there because of the 7 in the column. So this is 1, 3, 4, 5, 6. This is 1 through 3, 4, 5, 6. Yeah, because that's 7 that way. So the rest of column 3 is 4 through 9. Okay. Hmm. So this is column 4 through 9. We know these 2 are the same region. Since this is the same region, this must be the same region as that. So either this is 1 or it's 3 going that way. This is the same region. This is the same region. So either it's going 1 that way, because it sees only 1 that direction, or it's 3. It can never be 2. Same with this. It sees either 1 this direction, or it sees 3. I'm not sure. Well, if this... These 2 are the same region. One of these is going to be at least 1 or... One of these has to be 2. Oh, that's interesting. So then it goes there and it stops. There and it stops. So these must be the same region. We know that for certain. Because this is at least 3 in the same direction. So this must be part of the same region here. Because this sees at least 3. Um, hmm. So this has to be 3 through 9, right? Say this was a 9 here. That would mean the one of the cells would be in one of these cells here. So say it was here, which is the closest one to here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this can never be a 9. Could be 8 so far. Um, this could potentially be 3 and 3. If it's 3 and 3, obviously it's 3 that way, and then 3 this way, 3 that way. So it'd be 5 essentially in this 5. Oh, this can never be 7 here. If this is 7, the coordinates of this have to be... Well, I guess it can't... It could be 5, 4. No, then that doesn't work. 5, 4 could only be connected to here, right? And these would not add up to the same... Because they are in the same region, they can't add up to the same sum. So this can never be 7. Remaining digits in column 2 is 3 through 9, right? So if this is including this cell, is that ever going to be possible to be in the same region? So you would have to have guaranteed this amount. I think the answer to that is no, right? Hmm. I guess it's... Well, no, it's not really possible. This can't be 7 because of the 7 in the column. Or 7 in the row. But... I guess... The problem is one of these would have to end in 3. And this would be a 2, essentially. It would... So, where would it access the 2 in this region? Right? I guess it could go out that way. That's possible. But the problem... Okay, so the problem with this is... This necessarily has something from column 4 to column 8. I guess they could point to the same... No, they can't point to the same one, because they're in the same region. So since they're in the same region, these 2 digits must be in the same different digits than that. So I think we've shown that you can't include this arrow in this region. If you try to, this is guaranteed to have 7 cells. These coordinates must be different than these coordinates. So they're pointing to 2 completely different coordinate sets. You need a 2. But you're pointing to 2 completely different coordinate sets. I guess... And those coordinate sets cannot be consecutive with each other. They can't form, essentially, a domino together, essentially. Right? Because one's going to be like 3 and 5, the other one's going to be like 4 and 6, and that's the closest you can get, right? So 3 and 5, and then 4 and 6, but they're going to be a diagonal from each other. So they're necessarily going to have 2 other ones that they can attach to. this is 4. You could potentially have 5, 4, but again, this can't add up, right? These can't add up to the same value. So it has to have an extra one somewhere else, and it's not going to be this coordinated arrow. Because you can only the only way you can have a domino is if they either in the same row or the same column. And since there are no duplicates in the region, because of the chaos construction rule set, these cannot ever be in the same row or column, which is why they're pointing to two completely different variables. Though I guess this could be column 3, right? And the domino is that way? So maybe that is possible? It would have to be 5, 4 here, though, right? And then these two would add up. So the only way this could work is if this is 5 and 4, this has to point to a 3. And it has to be 5 and 3, which doesn't work. Right? Okay, so this can never work. The only reason why I was thinking this is that this points to this cell. Otherwise, if you use some other 3 here, I guess it could point to that technically. But okay, so then that, if you have another cell here, it points to that. This is definitely in columns 4 through 8. And that's problematic because the only ones that fits with just one cell would be going this way, right? And this, so this would be 5, 4, but then this can never be 5 because it's in the same region. So that doesn't work. So this can never be the same region, which means this is 3 or 4 at most. Okay. Technically, well, you could technically have a region go that way, but that's, again, too much, right? 1, 2, 3, 4, 5, 6, 7, 8. And then both of these point to somewhere that's not, this one points to something that's off the region. That is not in the current 8 cells in the region, I should say. And then you can't add to that with a single cell. So this is effectively a different region then. Okay. This is kind of weird. So can this be 8? If this is 5 and this is 8, that could work. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's possible. Interesting. If this is 1, that means this has to go this way and would be part of this region. If it's 3, that would mean this is 4. And this would have to be part of that region. So this region always has a 1. Either this is 1, and therefore cannot see any other cells this way or this way. So then it goes that way. Or it's 3, which makes this 4, and then this is a 1. Right? So the pink region can never have a 1 in it, interestingly enough. Okay, so what happens if this is 1? If this is 1, this cannot go down here. because then this one is blocked. So then this would be 3 going this way, which would force this to be 2. So this goes only 2 that way. This would not be 3, not be 3. So this would be a border. You'd have a border here, a border here. So far that's okay. This is a border that way. This could not be 2. So this is either 1, it can never be 3, it can never be 5. So it'd be 1 or 4 going that way. I mean, that seems okay-ish. This 1 means this can't be 1, so this is 2, which means this is the same region. That's fine, which means this can't be 2, so this is the 2 in column 3. So then these 2 are the same region, which means these 3 are the same regions. So this cannot be... This can never be 1 in this instance. Actually, it could be 1. It can never... Sorry, it can never be 3 in this instance because... Well, it could be. Never mind, this could be the same region. Ah, no, it can't because this is 2 and this is 2. So these would have to be different regions. These are different regions. Therefore, this can never be 3. Therefore, this is 1, which makes this 3. So this can't be 3 there. This must be C, all of these cells. That works so far. Okay. Huh. Yeah, this all looks kosher so far. These are 2 different regions, so it can never be all 6. This can't be 2 because of the 2 in the row. This is 1, so this is not the same region as the orange. So it could be red. Could be some new one, yellow. This is probably orange, if that's the case. So far this is looking okay. Let's go down the other path then, of what happens if this is 3. So if this is 3, then that means it sees both going this way. This is an edge of a boundary. So this can't be 3. These are its own separate region. This can't be 3, it must be 4. This can't be 3. So this can never be 3, essentially. Interesting. Since this is, if this is 3, if this is 1, this is 3, so that can't be 3. If this is 3, obviously it can't be 3 here. So this is 1 or 2 going this way. That means this is either 1 going here, 2, it could be 3 if this is 1. It could be 4 if this is 2, but it can never be 5 here. Interesting. So what happens if this is 3? If this is 3, this is 4. That means this can't be 4. This has to go that way. So this is size 6. So with these 4, it would add up to 10. So these are separate regions. And this goes only 3 that way. So you can't have 4 in the region. This can't be 4 either. This can't be 3 or 4. How does it access this then? The only one it could access would be 1, 5 here in that case. Right? You have to have column 5 through 9, and it's part of the region. So this would have to be 1 and 5, pointing to here, which would fulfill this only if it's this way. Therefore, this would not work, because this would have to be 1 or 3, but we already have 1 and 3 in that region. So, we have shown this can never be 3. So this can never be 3 here, therefore this is a 1. We'll mark this as green, I guess. So this is blocked this way. This 1 eliminates 1 in the rest of the column, so this is 2, which means that's its own region. This can't be 2 because this is blocked this way, because it can't be enter the 1 space. So this is 3, which means this can't be 1 or 3, that's 2. This cannot be 2, it cannot be 3, because if it's 3, it has to include that region too. This must be 2. So this goes that way and is done. So this is blocked also. So this is some other region, because it can't be the same region as this, because it has a 2. None of the rest of the green of column 2 can be 3. So this is red. This is green. This can never be 3, so this must be 1, which makes this a 3. So this is light. It has to go that way then, and then its border ends. This has a border here, so this is a border with the 2. This red cannot go any... Can it be part of this? Maybe 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No. So the red has to be a separate region then also. Which means this must be 1, 2, 3, 4, 5, 6 at minimum. 7, 8. So this is definitely going out this way. The rest of column 1 has to be 3 through 9. And these can't be 3 because of the 3 in the light region. These are 3 through 9. And this is 3 through 9 here. So yellow gets stopped here. This could be red. That's fine. This, again, is only 2. It could still be green, but we're going to mark it as pink for now. So it goes 2 and then stops. This light needs an arrow, which is part of the same region. So we have 4 and 4 as possible. But that would be, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 4 and 4 doesn't work. This cannot be 4 or 1, 2, 3. It's not possible. So it can't access rows 1, 2, 3 in columns 1, 2, 3. So the next one is 4. That's not possible. 4, 4 is not... it couldn't even be 4, 4 anyways. I think this has to be row 4 and column 5, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9. And then column, anything else in column 5 does not work. So 5, 6 obviously doesn't work. It's too long. Any column 6 doesn't work. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Because it's at least row 4. So this has to be then row 4, column 5. And this is the same region. So this must be the domino, which means this adds up to 9. This can't be 4, 5. This adds up to 9. So it's either 1, 8 or 2, 7 because it can't be 4, 5 or 3, 6. And 1 and 2 cannot be here. This can't be 7 or 8. This is a full region here. This can't be pink. And pink has to get out. These are 2 separate regions. If this were green, the problem is this would not be able to go out. So this cannot be green. These have to be separate regions. This must be part of green then. Pink has to get out. So it gets out here. That's 4. So these are separate regions. Therefore, this must be a 4 to be able to go that way. So this cannot be 4 in the same row. This can't be 4. This can't be 4 in the same column. This can't be 5 in the same column. This can't be 4 in the same row. This can't be 4. This is a boundary here, therefore this must be 1. It's because it's 2 at most, and 2 is not available there. So this we're going to mark as medium, and this will mark as dark, I guess. This can't be 1. This green is stopped here. We have column 5, 6, 7, or 8. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. That's not possible. Maybe I'm not understanding something about the rule set here. Yeah, this says it has to be in the same region. No, are also in the same region as the arrow. Hmm. 2, 3, 4, 5, 7, 8, 9. Oh, no, it does work. This has to be, yeah, this has to be 5, and this is 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's that region, which means this is yellow, which means all of this is red. Okay. So all of green is done. That means this is all pink. It has to go out. 1, 2, 3, 4, 5, 6, 7, 8, and 9. So the 6, 5 points to row 6, column 5, and that's the only one it can access that's in column 5. This has to be yellow going out that way. This arrow, it has to be, it can never reach column 5 because that's 1, 2, 3, 4, 5, 6, 7, 8. It can only reach column 3. So one of these is a 3, which means that eliminates the rest of column 3. Or 3 in that region, shall we say. Let's draw a border around the entire grid so that we make sure we have all those. This arrow, 6, 5, points to here. So this is 4, 7, adding up to 11 as a pair. Therefore, this can't be 6 or 7. This can't be 6 in the rest of the column. This can't be 4, 7. It can't be 5 or 6. This is 8 or 9 here and 8 or 9 here. This 4 eliminates 4 from the rest of the region. So this is done as a region here. This 4, 7 pair eliminates 4 and 7 in the rest of the row. This is column 3, and then it must be row 8 or row 9. So this is 3 with 8 or 9 here. The rest of this gray region is 1, 2, 6, 7, 8, 9. Obviously, 2 can't be here, 1 can't be here. This 4 eliminates 4 here, so it's 7 and 4. 7 cannot be in the rest of the column, so it can't be 7. The rest of the pink region is 1, 3, 5, 6, 7, 8, 9. This can't be 5. These can't be 5. These can't be 6 here. Where is the 5 in this pink region? It must be one of these two. These cannot be 7 because of the 7 in the column. This yellow has to be part of these cells here. It has to get out, so therefore it must be both of these. So this is 1, 2, 3, 4, 5, 6, 7. The rest of these digits are 3 through 9. This can't be 4, 7. This can't be 4. Hmm. Can it ever be non-4 column here? Or non-4 period? Well, if it's 4 here and 7, 8, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, it can't reach row 4. So this, if it's not column 4, it's 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, and 9. You could reach 7 and 7, but that's not possible as a coordinate. And that's the only one you can reach. So this is definitely guaranteed to be 4. So this cannot be 4 here. We need a 4. So one of these is 4 here. And this can't be 4 because of the 4 in the column. We need a 4 for the red region, so this is 4. This cannot be yellow, so this must be red. So red is all done. So column 4 works, kind of, maybe. This, can it ever be yellow? I think the answer to that is no. Right? So if it's yellow, it'd be 1, 2, 3, 4, 5, 6, 7, 8, 9 in that space, and this cell would not be part of a region, which is not allowed. Obviously can't be more than 3, so since it can't be part of yellow, this is 1 or 2. That eliminates 1 and 2 in the rest of the column, so this can't be 1 or 2. This can't be 2. That means this can't be 1. Well, in the light region, this is 1 or 2. Where's 2? It can only be here. So this is 2, which makes this 7 to add up to 9 for these cells. And where's the 1? It has to be here. So this cannot be 7 anymore. This can't be 7. This can't be 7 either. So this is column 4, 7, or 8, or 9. Okay, so this rest of this pink cell cannot, pink region cannot have a 1 in column 4. Whereas the 1 in column in the pink region, it must be there. Okay. Hmm. So the white, so this arrow's this blue, um, blue arrow is done. This arrow is done, right? Row 4, column 5, which adds up to the same sum, 2, 7. 3 is done, 1 is done. 6 and 5 work as row 6, column 5 adds up to 11. This is only sees 1, this sees 2, this sees 1, this sees 2. We don't have these arrows done yet. This is 2, so this must be 1. Interesting. Okay. That means there's a border here. This can't be 2 because of the 2 in the row. Where are the remaining ones? One can be here, or one can be here in the grid. 2s. This must be at least 3. I guess we'll make it orange. Remaining, the 7 eliminates 7 in the rest of the column. The remaining digits in column 5 are 3, 5, 6, 8, and 9. Okay. Remaining digits in column 4 are 3, 5, 6, 8, 9. We also know in column 3, where are the 6 and 7? They must be in the pink region. That eliminates 6 and 7 in the rest of the pink region. So one of these 2 is a 6, one of these 3, this can't be 7. One of these 2 is a 7. What are the remaining digits in row 1? We have 2, 4, 6, 7, 8, 9. Remaining digits in row 3 are 4, 5, 7, 6, 8, 9. Okay, this can't be 7 because of the 7 in the column. I guess this medium gray could be the same as this one. That's possible. It still could be all 6 there. So it could be dark too. Interesting. 1, 2, 3. So 4. Rest of row 5 have to be 2, 3, 6, 7, 8, 9. This 5 eliminates 5 here. This 6 eliminates 6 here. Oh, this cannot be 3, 8. If this were 3, 8, then this 1 would have to add up to 11 with another digit, which is not possible. So this must be 3, 9. That eliminates 3, 9 in the rest of the column, or the rest of the region. That means this is a cell plus this cell, adding up to this cell. So this must be an 8. That eliminates 8 in the rest of the region. So this 8 eliminates 8 here, so this is 9. This can't be 8 or 9. This then must be 7 and 4. Which we kind of already knew anyways. This 5, 6, 7 triplet eliminates 5, 6, and 7 in the rest of the region. So this can't be 6. It can't be 3, 9 because of the 3, 9 pair in the column. So this has to be an 8, which eliminates 8 here. This is a 6, 9 pair, which eliminates 6 and 9 in the rest of the column. So this can't be 9. This can't be 6 or 9. This 8 eliminates 8 here. This 9 eliminates 9 in the rest of the row, and it eliminates 9 in the rest of the region. So this is 8, which means this can't be 8. This is a 6, 7, 9 triplet, which eliminates 6, 7, 9 in the rest of the column. So this can't be 9 here. This is then row 7, column 4. So row 7, column 4 adds up to 11. Okay. None of these can be 5 because of the 5 it having to be one of these two cells here. Technically, this could add up with this to add up to 11. We don't know, though. Hmm. Hmm. Rest of row 8 is 3, 5, 6, 8, and 9. Rest of row 9 is 2, 3, 5, 6, 7, 9. And this can't be 7 because of the 7 in the column. Okay, so 4, 5 points to this cell. So let's mark all the cells that are pointed to. 4, row 4, column 5. Row 6, column 5. Row 3, no, row 9, column 3. This is row 7, column 4. And we don't know what this one is. We don't know what these are or these. Okay. So in this arrow is only 3, 5, 6, 8, 9. I think you have to have either 3, 5, or 6 in that set. You could. Can you ever have 6 and 5? You potentially could. So 6 and 5 does work. No, it doesn't, because this is 6 and 5. It would be 6 and 6. You could have 6 and 8, potentially. Right? 1, 2, 3, 4, 5, 6, 7, 8. So 6 and 8 works. And therefore, it would be 5 and 9 together. So 6 and 8, and this would be 5, 9. And then you could have 3 and 8. And that does kind of work. So 6 and 8 works. Or 8 and 6, really. But this, if you have 3, it's with 7. Because you can't get to row 3. And so this can never be 3. If you have 5, it can't be with 7. It could be with 8. But if you have 5 and 8, this can't be 5 or 8, it's 3. So that actually doesn't work. So again, if this is 5 and 8, it would be row 8, column 5. It can't be 9 and 5 because that would be a 1. And we already have a 1 in the region. It can't be 9 and 6. It can't reach there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 would be 6 and 9. And this can't be 9 anyways. If we try to have 8 and 5 again, that would force this to be part of it. And the problem is 3 and another digit can never add up to 13, which is what 5 and 8 would add up to. So this has to be 6 and 8 then. So this is 6, this is 8. Which means it's row 8 in column 6. So this is part of yellow. This 8 eliminates 8 here, so this is 3. This is part of the region, so it has to be 5 or 9 to add up to... this 3 and 8 eliminates 3 and 8 here, so this is 5, which makes this 9. This is surrounded by just yellow cells, so this must be a yellow cell here. And this is the full region, so this is 3. So 4 and 7, so row 7, column 4 points to this cell. Row 8, column 6 points to this cell. So this region is, the yellow region is done. We're going to make this blue. So this has to be blue, which means this is part of blue. 1, 2, 3, 4, 5, 6, 7, 8, and 9. So it could be part of, this could be part of blue also, except that this has to be part of this region. So it can't actually be part of blue. This is the same as this orange then. Because there's no other cells in that cell that works. This 3 eliminates 3 here, so this is 9, this is 3. That means this can't be 3, that means this is at least up to here. Remaining digits in row 8 are specifically 3 and 8. Okay, this can't be 3 or 6 because of the 3 or 6 in the column, so this is 9, which eliminates 9 in the rest of the row, and this can't be 3 in the rest of that row, or column. This can't be 3, there's 2, 6, 7, 8 here. This is either orange or blue, we're not sure which. We need access to a 3 or an 8 here. I don't think it can ever be 3. It doesn't access any of the column 3. Can it ever reach row 3? 1, 2, 3, 4, 5, 6, 7, 8, and 9. No. So this must be 8, which makes this 3. So we have probably row 8. And it would be row 8. Okay, never mind. It's column 8. So I think it has to be 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is either 5 or 6. So if it were row 8, it would be with column 7 or column 9, but that can't be 7 or 9 here because of the 9 in the row and the 7 in the column. So it must access up to here. So it cannot enter in through this way, because if it did, it would have to be part of that cell, and this would be too many cells. So it must go through this way then. Border has to go here. This cannot be 6, 8 because that forces to be 5, 9. So this has to be, and we already have a 9 in that region. So this must be 5, 8. That means it enters here. So this is 1, 2, 3, 4, 5, 6, 7, 8, and 9. Interesting. This is then likely either part of the dark region or the light region. 1, 2, 3, 4, 5, 6, 7, 8, and 9 is possible. So we'll mark this as, I don't know, one of the grays. We'll mark it as medium for now. We don't know. This is either blue or an orange. We're going to mark this as the orange region, so it has to go up to here. We know this is a boundary. This can't be 3 because of the 3 in the column. This can't be 5 because of 5 in the row. That means this 6, 7, 6, 7 pair in column 1, which eliminates 6, 7 in the rest of the column. So this is 5. This 5 eliminates 5 here, so this is 8 and 5. Five and 8 add up, so this is done. This is the edge. So it must go down. 5 and 8 add up to 13. We don't have 4, 9 available, so it's 6 and 7. So this must be a 6, 7 pair. The blue does not have access to a 1. So this can't be 1, which makes this a 1, which means this can't be 1 here, which makes that a 1. So this is not orange, because orange already has a 1 then. This cannot be dark. This must be medium. Six, 7, 8, 9. How does this work? We have 1, 2, 3, 4, 5 regions. Oh, this is not medium. Sorry, this part's not medium. This has to be with dark. So this is dark. Must be medium. So this cannot be medium because it can't reach here if that's medium. So then this is dark. So this must be all dark, which makes that 6, right? 1, 2, 3, 4, 5, 6. Right, it has to be. So then this has to go medium around. It has to go this way. Orange needs, so we have 1, potentially 2, 3, 4, 5, 6, 7, 8, 9 at least. Gray has to go all the way around. It could enter here, so this is gray or orange, we don't know. Medium gray. This could be, this can never be dark. If this is dark, what color is this? That's 1, 2, 3, 4, 5, 6, 7, 8, 9 guaranteed darks, and this cell would not have a region. So this is medium. This could be medium or dark. We don't know. So this is 6 pointing up there. That's done as a border. This is a border. This 6, 7 pair means this cannot be blue. So this must be dark, which means this can't be dark. That's medium. So that's 1, 2, 3, 4, 5. Right, the blue has to connect, so this can't be orange. Therefore, this is not medium gray, it's orange. So these are the regions. The 6, 7 pair eliminates 6 and 7 in the rest of the blue region. This can't be 6, 7. This is a 2, 3 pair, which eliminates 2 and 3 in the rest of that region. So this must be 4, which makes that 5. This can no longer be 5 because of the 5 in the column, nor 6. This can't be 6 either. This 6, 7 pair eliminates 6 and 7 in the rest of the column. So and you can't have 4, so it must be 2, 3, 5, 8, and 9 here. It can't be 8. 2, 3, 5, or 9 in the rest of column 8. We know 5 has to be here. We know 9 has to be here. That eliminates 5 and 9 in the rest of the medium gray region. So this can't be 5 or 9. This can't be 9. These can't be 8 because of the 8 in the row. This can't be 8 because of the 8 in the row. This arrow needs to be 9 because we need to have a 9 column. So this must be 9, which eliminates 9 in the rest of the column. You could do any of the rows. So 2, 6, 7, or 8 are possible. This 7 eliminates 7 here, so this is 6 and 7. That eliminates 7 here, so it's 6 and 7. Which means this can't be 2 or 7, it's 6. That eliminates 6 in the rest of the column. This 7 eliminates 7 in the rest of the row. So this is a 2, 8, 2, 8 pair. Remaining digits. So this cell, this 5 matches this 5. This cell must be the same as this, and it cannot be a 4. So this must be a 2. So that's 2, which makes that 2. So this can't be 2 anymore. That's 9. That can't be 9, so it's 5. This 2 here eliminates 2 here, so it's 3 and 2. That means this can't be 2, 5, or 9, so it's 3. 9 eliminates 9 here, so it's 6 and 9. This can't be 2 or 6. This can't be 2. This 9 eliminates 9 here. This 9 eliminates 9 here, so this is 7, which makes this 6, which makes that 9. So this can no longer be 9. This can no longer be 5. We have a 4, 8 pair in row 3, which eliminates 4 and 8 in the rest of the row. So this can't be 4, 8. It's 6. So we have 5 and 8, or rather, yeah, row 5, column 8. So that's that cell. If we have 8 and 9, there's no other two pairs that can add up to 17. So this must be 2, which makes this 8. That means this can't be 8. That's 4, which makes that 8. This is 2 and 9. And if this were... So basically it's row 2, column 9. This cell cannot add up with 8 to add up to 11 because we already have a 3 in the column. So this must be 4 or 7. Can't be 4 because of the 4 in the column. So this is 7, which makes that 4, which makes that 7. That makes this 8 and this a 4. That leaves this as a 3. So 2, 9 points to that cell. This is only a 9 remaining, and that leaves that as a 5. And that's a solution. I don't know if I would consider this challenging. I think I would make this hard. This is more difficult than... I mean, it's... I think the chaos construct... Well, I don't know. Maybe I'm just not good at coordinate arrow stuff. But this took a while to actually figure out all those possibilities. And I felt that it was not intuitive, I would say. Yeah, I would consider this hard, but, you know. People have their own ratings and stuff. Well, I don't even know if it's considered easy on the scale for chaos construction either. Maybe it's because I don't do coordinate arrows very much, but I felt that the coordinate arrows was not simple to try to understand. I don't know. Anyways, let me know what you guys think. Did you guys think this was just challenging or was this hard? And I'll see you next time on Frank Puzzles. Take care.